Let's take a look at exponential functions. So previously we had looked at a lot of linear functions, which means that the pattern between the numbers is changing by adding or subtracting numbers. Exponential functions look a little bit differently because this time what we're going to be doing is we're going to multiply or divide, but remember that multiplying is can be written with a fraction, which is how you would show division. So for example, if you're dividing a number by 2, that's the same thing as multiplying it by 1/2. So just something to keep in mind as we're working through these exponential functions. So let's take a look at the first question. It says, tables of values for 4 functions are shown below. Which table best represents an exponential function? So again, that wording is letting you know they want to see a pattern that's showing multiplication, okay? So if I look at my y values, my f of x values, I should be more specific, we want to see if these patterns of numbers are showing a common pattern. So to get from 6 to 7, from 7 to 10, from 10 to 15, from 15 to 22, we're not multiplying anything to get from those numbers. So choice 1 is out. If you look at g of x, which is underneath, to get from 0 to -2, we would be subtracting 2. But then -2 and -2, nothing's happening. And so for that reason, choice 2 is going to be out. That is following, if you can kind of see, your quadratic pattern, because you sort of see that symmetry. The 4 would probably be on top with -1 matched up. Remember, we look for that symmetry when we're looking in a quadratic. H of x, to get from 1 to 2, we can multiply by 2. To get from 2 to 4, we can multiply by 2. 4 to 8 multiplied by 2, 8 to 16 multiplied by 2. Well, there you go. That's the pattern that we're looking for. Whereas in choice 4, you could see to get from 2 to 5, you're adding 3. 5 to 8, you're adding 3, and so on. So that is what we call a linear function, which is why choice 4 is out. Let's take a look at the way that questions can be worded. So the second one says, which situation represents exponential growth? Aiden adds $10 to a jar each week. A pine tree grows 1.5 feet per year. Ella earns $20 per hour babysitting. If you notice, all 3 of those answer choices kind of sound very similar. Whereas in the last one, the number of people majoring in computer science doubles every 5 years. When you see words like doubles, triples, that's going to be something that you're multiplying by, which is an exponential growth. So keyword like doubles, and anytime that you see a percent in the question, that is also going to be exponential. Okay, let's take a look at another type of question here. The inputs and outputs of a function are shown in the table below. So as you can see, our x values are increasing in order. So now what I'm going to do is look at my f of x values to find a pattern. This function can be described as, let's see what we notice. I'm going to go in reverse order to talk about the answer choices. Absolute value is this symbol. And what that means is if I take the absolute value of a number, that just equals the number's distance from 0. And so for that reason, choice 4 is out because you wouldn't have different numbers in your x and your f of x columns. Okay, so I'm going to look at quadratic. When you're finding these functions, unless there's that symmetry shown, we can't tell whether a question is quadratic from this yet, unless we find our first and second differences, which we're not going to need to do for this question. So now we look and we say, okay, am I adding the same thing every time, or am I multiplying by the same thing every time? And if you notice, it's a little bit easier when you see at the bottom, to get from 1 to 2, you're multiplying by 2. To get from 0.5 to 1, you're multiplying by 2. And so as you see this pattern, if you work backwards, you'll notice that every time, you can even check in the calculator to make sure that when you multiply by 2, you get the next number that's in the pattern. And so I'm showing that on the screen on the left, that every time I multiply by 2, I get the next number. Okay, so now we're going to finish this up by practicing graphing some exponential functions. All right, so I'm going to go into my y equals, and I'm going to type it in exactly the way that I see it. And it's really important to remember that you want to fill in a table. If they don't give you a table, which they most likely won't, you need to create that table yourself. So we're going to first fill in the numbers that are coming up from our table, and then we are going to graph it. Okay, these all follow a pretty similar pattern. And so it's a little difficult at first when you're trying to plot the points because they're really kind of in a very similar position. But then you'll kind of start to notice what happens. And we're going to connect those dots together. We're going to make sure that we're curving that line and extending it with an arrow in both directions. And it's not going underneath that 0 for right now. Okay, that's it. We're going to label f of x is equal to 2 to the x power. So we're going to look at our next example. I'm going to go back into the y equals, clear out what's in there, and I am going to type it in exactly the way that I see it. And I have my 1/2 that's being raised to the x power. There we go. Okay, double check, make sure it looks exactly the same. And now I'm going to go to my table, get my values, and for some reason in my calculator, this question is not working for the moment. So you should be able to continue. But what we could also do is raise that 1/2 to the -3 power. Okay, so I'm going to raise that 1/2 to the -3 power, and that gives you 8. So for some reason in my calculator, that's not going through, but that's okay. We can just kind of roll with it. We've got an 8, we've got a 4. I'm going to just keep grabbing it and kind of going back and plugging it in, which gives us a 2. And hopefully you'll start to notice the pattern. We're just dividing by 2 every time. So every time we divide by 2, that's what continues in our numbers. So now what I'm going to do is graph. -3 is going to be lined up with 8. So -1, 2, 3, and we go up 1, 2, 3, 4, 5, 6, 7, 8. Then I've got a -2 going with 4. I've got a -1 with a 2. 0 goes with 1. 1 goes with a 1/2. 2 goes with a 1/4. 3 goes with an 1/8, which just means it's getting closer and closer to that 0 value. And I'm going to continue. Okay, make sure that your line is not curving upwards, kind of like some kids tend to put their arrow going like that. That is not what this should look like. It really needs to be following that same exponential pattern. And I'm going to write f of x equals 1/2 to the x power. All right, and I've got one last example we're going to take a look at here. So that's going to be 2 to the x minus 1 power. When I go into my table, all right, I've got some good numbers this time. So that's going to be 0.0625, 0.125, 0.25, 0.5. I'm going to scroll down to get a couple more numbers. I've got a 1, I've got a 2, and a 4. So now those decimals might look like they're a little difficult to plot, and that's okay. -3 is going to be really close to 0. -2 is going to be pretty close to 0. -1 is going to be at that quarter mark. 0 is going to be at the halfway mark because 1 goes with 1, 2 goes with 2, 3 goes with 4. And if you wanted to put one more on there, 4 would go with 8. You could throw that in there to kind of make this look a little bit nicer. So I actually have a point at the wrong spot. Let's just fix that up. So 3 is going with 4, which is here, and then 4 will go with 8. So 4, 5, 6, 7, 8. And that kind of just helps to see your shape a little bit better. So notice that all of these are following the same general directions. They have that same sort of shape. And so that's what you want to make sure when you're graphing an exponential function, that it follows that shape.